My name is Jakub Warczarek. Today we're gonna talk how to answer tricky questions the SRE way. Let's answer the first tricky question. What is SRE? It may vary between different organizations. So let's define SRE as short as possible to make sure that we're all on the same page. I like the most this definition. Site reliability engineering is the specific implementation of DevOps with some idiosyncratic extensions, which treats operation as a software problem. We can think about the whole DevOps as an interface and about the SRE as a specific implementation of this interface. So what are those extensions? There are 3 of them. SLI, Service Level Indicator. Clear numerical indicator aggregated over time that informs about the health of the service. For example, request latency, batch throughput, failures per total number of requests, and so on. Metrics that we want to use as SLIs should be chosen carefully to correspond with the satisfaction of customers. SLO, Service Level Objective. It's an agreement among stakeholders on how well we want to do on the chosen SLI. We might set a target for uptime that 99.95 requests end with status code 200. Or it might be a performance objective that 99.95 requests are served under 200 milliseconds. Or something else. Whatever makes sense for our platform. I mean directly corresponds with user satisfaction. Who are the stakeholders? It depends on the organization, but it should be broad. The most typical are product, developers, SREs, management, etc. Error budget tells how many interruptions can be tolerated. It gives room for experimentation. It answers the question of what to do when the system is not meeting its reliability goals defined by SLOs. When error budget is exhausted, everybody follows previously defined policy. For instance, halt delivery of new features, only reliability improvements can be deployed. In short, the team puts extra effort into making the service more reliable to not lead to happen this situation again. It might sound similar to SLA, Service Level Agreement for some of you, but it's a little bit different. SLA is a business agreement between a customer and service provider, often based on SLO. Usually, it offers low values than SLO. Why? Because we want to have a safety margin to avoid penalties for not meeting it. Moreover, SLO should be used more as an internal tool to have a meaningful and effective conversation in a company about the product and its reliability. SLO shouldn't be viewed as a tool to punish someone. Second tricky question. Why you shouldn't aim for 100% reliability? Molly used to be a hairdresser. When she first started cutting hair, she was so focused on making sure everything was perfect that it would sometimes take her twice as long as should to do a simple man haircut. Trying to be perfect caused too many haircuts to run over in time, which upset clients that had later appointments booked. When she gained experience, she realized that trying to be perfect didn't really do much for anyone involved. It was more stressful for her. It was more time-consuming for everyone, and it didn't actually improve anyone's life. She discovered that customers were happier with the shorter time the haircut took, and they didn't notice slight inaccuracies. They had only praises for her. How can we translate this story into the software world in one sentence? Just be good enough. Wanting 100% reliability is pointless. Faster features shipment is far more important for customers than 100% reliability. Short service outages are indistinguishable for a user from, for example, a Wi-Fi router being slow or ISP having a problem. Those sorts of problems with platforms users even don't notice. It's crucial to know how users use the application, what is their experience, and how much impact we have on it. For instance, consider a mobile app that connects to a backend through a cellular internet connection, and most of the clients use it in rural areas. Such internet connection is often crappy in terms of performance and reliability. Even when our app processes a request very fast and it's highly available, customers can't experience it from factors that we can't control. So investing in maintaining a tight SLO is pointless. To sum up, we should know what to measure and where, and how it corresponds with the real-world experience with an app. Tightening SLO is not a piece of cake, because adding only 1 line to an objective requires us to improve 10 times. So for example, time of allowed unavailability of service for 1 year time window has to be reduced from almost 9 hours to just 52 minutes. Improving something by order of magnitude is always hard and it costs, in terms of infra, engineering time, slower feature development, and so on. Hence, as a low target should correspond with business expectations and pay off. Solid question or paradox. When being too reliable leads to being reliable over time. Let's learn from Google. Chubby is an internal system which provides a distributed log service for loosely coupled distributed systems. It has a certain SLO, but it used to be always far more reliable. Was it good? No, because other systems started to treat Chubby as 100% reliable. Engineers begin to add more and more dependencies to Chubby. Some of them weren't even needed. Google learned the hard way that Chubby outages degraded the stability of many different systems. Lesson learned. Now, SRE makes sure that Chubby meets but does not significantly exceed its SLO. In this way, Google engineers are able to flush out unreasonable dependencies on Chubby shortly after they are added. Services by design might try to cope with the unavailability of Chubby gracefully. It makes the system as a whole more reliable. Making outages on purpose is quite similar to the concept of chaos engineering. Chaos engineering is the discipline of experimenting with a system in order to build confidence in the system capability to withstand turbulent conditions in production. But chaos engineering is a big topic that can take the whole conference just like SLO. So let's better move on and try to answer the next tricky question. When speeding up the application 2 times doesn't improve the user experience. Let's consider this simple example. We have our application, which gathers data from a third-party system over which we don't have any control. Next, there is a processing pipeline that makes some computations and saves results to the database. From it, results are served to end user of our application. Engineers spot that implementation of non-trivial optimization, which will take 2 sprints, can reduce the duration of the processing pipeline from 5 seconds to 1 second. Making something 5 times faster is great, isn't it? It should be acknowledged by customers, right? It depends. In this case, the time taken by the processing pipelines is negligible for the overall experience. The biggest problem is the delay introduced by the third-party system. It equals 2 minutes. Thus, even if we can be 5 times faster, our customers don't experience it. So 2 sprints of work deliver nothing useful for customers. This example is simple, but you've probably seen something similar during your career. Having thoughtfully chosen SLI and SLO protects from such situation. Now, the billion-dollar question in the industry. What should wake up on-call engineers? In the end, they are the first to fix stuff. Alerts should be only triggered when SLO may be violated. As I described it earlier, SLO has to be defined as something that matters to users' happiness. Metrics like CPU usage, disk space, and so on don't matter when they don't affect customers. We shouldn't wake up engineers to fix them. Maybe we can live with this for a couple of more hours without degradation of users' experience. Engineers can fix them during normal working hours. We should be alerted of the risk of burning the entire error budget. This is the wake-up call. It's called burn rate. It tells how fast the whole error budget will be exhausted. Of course, we want to avoid it because it means violation of previously defined SLO. When we adopt the SRE mindset, the question, should you focus on reliability or feature request, is no longer too tricky. A simple algorithm can give us the ultimate answer. Surplus error budget? Ship more features. Exceeding error budget? Focus on reliability. So simple. Just everybody needs to follow those simple rules without excuses. Now, a few key takeaways from my talk. Try to measure what users expect from your app and treat these metrics as SLI. Set a reasonable SLO for it and do your best to deliver it. Let's have meaningful conversation and make decisions based on SLO in your organization. Just be available enough, fast enough, and complete enough that the casual observer might think that is up 100% of the time. Please remember that no one is perfect, nothing is perfect, and no one expects perfection all the time. That's all. Thanks.